So, hi guys. So tonight we're going to do a show and tell. If you have a project or a demo that you would like to share with us, please drop your information in the chat box and we will put you in the queue. Welcome. Anybody want to start?
I can start or whenever, or if someone else wants to go, it's fine.
No, Jim, go for it. You were already in the queue because you already said you.
Yeah, I mean, I don't have, yeah. Just getting my video. I recorded a video. If we have time, I can do a risky live demonstration because I haven't recorded yet, but that's always fun. But most of the stuff I always record. I actually have two, but so yeah, I've been in this Open CVAI contest, and that's been really putting a fire under my feet to develop. And it uses the depth camera, depth AI, stereo and AI by disparity. So it's disparity depth using two eyes, and then the AI runs a neural inferencing. And I'm just running this YOLO V4, which is a pre-trained model with 80 objects. So it's got some household objects that are convenient, like a frisbee, a baseball or sports ball in this case. I'm going to change the how that said. It's a better demo to change it to baseball, but and other things, bottles and whatever. But so I'm going to show a video where the robot can go on its way across the room. It can see an object and then stop and get a reading on it and then go up to it, actually approach the object. So this is called the go to object on demand. Oh, wait a minute. Now I forgot if I chose the share audio. In this case, there's some text, but I think you don't need the text. So I'm just the text will be blurry, but don't worry about it. Hi, it's Jim from the Social Distancers group in the 2021 OpenCV AI competition. Today I'm going to show a couple of video clips showing the use of the Oak D camera to detect objects around the house and have the robot go up to them. Orange, find a sports ball in the home.
Okay. I'll search for a sports ball in the home. I'm going home.
On the screen here, you'll see the point of view of the robot through its color camera on the left. On the right, you'll see the map and the path planning to cross the room. In the bottom right, you'll see a camera view of the scene.
I see a sports ball. I'm going to the sports ball. I've arrived.
So it just goes up to like within a few feet of whatever the target is. Here's another. Orange, find a sports ball in the room.
Okay. I'll search for a sports ball in the room. Okay.
The model being employed here for detection is the YOLO V4. One of the challenges is to deal with the spurious nature of detection and applying filters appropriately.
I thought I saw a sports ball. I'll keep going. I see a sports ball. I'm going to the sports ball. I've arrived.
Orange, find a frisbee in the home.
Okay. I'll search for a frisbee in the home. I'm going home. I see a frisbee. I'm going to the frisbee. I've arrived.
Orange, find a person in the room.
Okay. I'll search for a person in the room.
Another issue to overcome is detection
Okay.
while moving, which can be a challenge.
I thought I saw a person. I'll keep going. I see a person. I'm going to the person.
Thank you for watching. So yeah, that's the go-to object on demand. Uh, what'd you think? Or any
Nice.
questions? Yeah, I guess I gave enough. I gave some background on that. Anybody? So I showed this, and that got me the Phase 2 award, which is Floorbot Challenge Phase 2, which is find an object. And it was also part of my goal for the Open CVAI competition. So I really like when multiple things kind of lead me to the same code or work.
So I have a question. First of all, I want to compliment you on your wonderful documentation of it. Beautiful job
Oh,
on
thank
that.
you.
Excellent. Um, can you program it to look for vital signs? Like, is there a way to get it? I was thinking of the building that collapsed in Florida. Is there a way to get it to search out vital signs? Like, would that be possible to program?
Oh, well, that's not with this camera or with this device. That it's just visual. Now, if you it's not in the infrared spectrum or anything like that. And it doesn't have audio, a real sensitive audio. But I mean, you need good sensors that could detect, say, body heat or through infrared infrared or some kind of sensitive microphone for that you could maybe attach to the ground or something that could hear tapping or, I'm sure that things like that could go in, and then with an AI system, it could essentially do the same kind of thing if it were trained. Like it would put the bounding box on there might be some life signs here, but not this is nothing like that, right?
Well, and actually, Jim, I would challenge that by saying that your robot probably could. But what I'd like to pivot a little bit to in the discussion is what constitutes life science. Like if we were to build a robot, unlimited budget, unlimited time, and we were going to give it whatever sensors were there, what what would we be looking for? What sensors, what type of things would we try to detect in order to determine what constitutes life in that context?
Yeah. Well, I mean, I'm just talking off the top of my head. I'm not,
Oh yeah, me
expert,
too.
but yeah, I mean, I would think, you want to hear a heartbeat, or you want to hear tapping, or you want to you want to detect heat, um, body heat profile, and which would come up with animals or people, those type of
Yeah.
things. You won't be able to get blood pressure or stuff like that unless you're touching a person, probably, or unless they're really close.
All
But
right, so we've got sound, we've got heat like a FLIR or an infrared, maybe carbon dioxide, checking
yeah,
for,
yeah, gases.
okay.
So they've been able to put some very extremely elaborate sensors onto drones. Would your computer or your robot be able to handle those same sensors? Like, could you take the sensors that go onto a drone that detects all of that and put it on your robot? Would it work?
That's an open question, but I mean, I can't tell you for sure, but I mean, it's a lower powered Windows computer. So if those sensors are compatible with Windows, you can also, I mean, make a robot like this with Linux system, but mine is Windows. It's not a hugely powerful processor, but yeah, if it's powerful enough to handle multiple camera videos, and so it could probably, a lot of things are built for Windows with Windows drivers. So I mean, I would venture to guess it's possible.
I bet your robot has a lot of potential in the search and rescue area.
Oh, I didn't even thought of that. I mean, if you if you gave it some better wheels, and maybe it is definitely maybe some different hardware probably to get over rough terrain. Obviously that's very different.
Yeah,
It's-
but it,
Well, if we discuss a less dramatic scenario, obviously this robot is not going to crawl over the rocks in the collapsed building. But inside the home, for example, if this robot follows an elderly person
mm,
all the time and watches after that, body pose and everything else, and then it could detect the fallen body. It
yeah.
can detect the body not moving. It can distinguish between the sleeping person, for example, or resting person, and person having some heart attack.
Yes.
that's a
Yeah,
great
with the
idea.
yeah, this is as a home personal assistant type of robot. It could be a home safety robot. In fact, that chassis there, that orange thing, is called the HCR home care robot. That's how they sell it. But yeah, that's a decent application, is to follow around people in the house, older people that may have memory impairment, and all sorts of things. And it could, you can detect heartbeat from quite a ways, and then certainly that camera has a pose model. I don't know if I think I showed it on this in one of these meetings, where it can make a stick figure and see what orientation you are. So that could be used, and then the not moving bit and any of that. So yeah, that's an application of a very important application of a home personal assistant robot. It would be safety.
And of course, the job of the person would be watching for the blue screen to appear on the robot
Yeah,
and watch for the robot, right?
yeah. I've never. That's one thing. This computer has never blue screened, although Windows forces updates, and I try to delay them as long as possible. So that's good old Microsoft will ruin your plans if you're not too careful. But thank you. Yeah, I mean that's a very interesting. And maybe after this contest, I could venture into some safety experimentation.
That would be cool. How much further do you have to go in the contest?
Well, the contest is due in 1 month. They extended it. It was going to be today, actually. So it's 1 month from today. And I'm kind of wrapping up things. Carl is involved too. Carl is one of the members. And I don't know if anyone else there's no one else with us right now on the call. Brian Erickson. But we are, we're kind of wrapping up the coding and then kind of shifting over to the presentation of all the features in a nicely documented and nice looking video, all that stuff.
Jim's doing all the work though.
Well, luckily there's a daughter involved. Carl's his daughter is going to help us with the filming, with the editing, because she's a film major. So.
Well, lovely job. Really great project. Excellent.
Yeah, thank you. I was in the right place at the right time, because all the last year and a half of working on the base and of all of this robot to enter the contest, which only started like 4 months ago. Was it 4 months? It's like January, right? January, February. But yeah, a lot of things start coming quickly once once you've got that camera working. And then I added a second. I won't demo it now unless there's no one else, but I have a second camera below that is for obstacle avoidance. So I'm feeding that into the essentially publishing depth data into the system, so it can see things that the LiDAR cannot see. It's slightly delayed right now, but it is maybe a bug, but it's working, or there's maybe a slight issue, but it seems to work. And I have a video of that if you want to see it, if no one else is going anyway.
Well, actually, before we move into your video, thank you for that. I noticed we have a timer, and I forgot to ask, is anyone here a first timer to the club meeting? Anyone? Okay.
Thomas.
All right. So just thought I'd like to say hello to you guys and welcome you. Does anyone else have a project to show? Okay, so with that off the table, we can go into your video. And are you ready?
Yeah, if you, yeah, no one else wants to. I can go at the end for any more.
Hey, Jim, give me a little bit. Might have something else. I just have to turn everything on and connect everything. Try to
Okay.
reproduce what I did with the HBRC that didn't work.
While Thomas is connecting,
Okay.
I'd like to have Jim tell us a little bit more about the contest he's in.
All right, yeah, now let me share again here. Okay, so this one is, when you're looking at this video, you'll see on the upper left is the depth map. It's in a colorized form, and the dark blue means that it really doesn't know what that is. That's essentially no confidence, so it doesn't report the data. And the brighter the color means it's closer, although it's not always that way. It's, I guess, I don't know, I might change this color map because it's not perfectly clear to the person, but in general, the brighter colors are closer, or more, maybe more saturated. So those really deep, those really bright blues. And then you'll see on the map on the right, these purple and red. The red is the LiDAR and the purple is the depth data being translated and into two-dimensional data that representing obstacles in the way, in the plane, it's really in the plane of that camera. So it's not exactly the same plane as the LiDAR. So let me just play this. Orange, go to end of hall.
I'm going to the end of hall. There's a chair in my way. I will plan a way around it.
So the robot was able to avoid chairs in the past just be from those red dots, which is what the LiDAR is seeing. So it would function fine without the depth, really. But the depth, for this example, but the depth will allow it to see things like a shoebox or whatever that's lower than the LiDAR. In this case, I was kind of demoing there's a chair in my way, which is an algorithm that I wrote sort of to self-describe what's going on. And it tries to see what's in front of it. And if something's in front of it for a certain number of seconds, and it's like centered and sort of, and then it decides to say, oh, there's that thing in the way. I'm not sure how useful that is. Orange, go home. But it kind of makes for an interesting video. So here you'll see it won't say anything until the object is within like 3 meters. I think I set it to. So even though there's a chair there and it sees it, it's not going to say anything yet.
There's a chair in my way. I will plan a way around it.
Yeah, it just said it. It's kind of hard to hear, but once the chair got within a certain distance and it's still sort of centered, then so this video is showing you two things. The purple stuff is the depth data, and the calling out of objects is from the AI. And unfortunately, like I said, that purple data is a little bit delayed, and that may be my CPU. We're not 100% sure, but that will help you avoid things like I said, a shoebox or something lower than the LiDAR, or something with a very minimal floor profile. Like if it only has, if it's just got one leg, you know, like it's a very small, yeah, if it's a one leg table, then the LiDAR may not see it. It'll just see it as a little tiny spot. Let me see what was this one. Okay, this is the same thing.
Hey, Jim, how did you teach it what a chair was? Did you have to show it multiple images of that same exact chair from different positions?
Oh, okay. Let me explain. This is the depth AI camera here. This Luxonis Oak D. You can load different models onto it that are pre-trained, and this is the YOLO V4. You only look once, version 4, which has 80 objects pre-trained. So I don't have to train. I didn't have to do anything other than test it to see, like point it at a chair and see that it does in fact think that thing is a chair. And so they trained it pretty well that my weird, well, I don't know how my chair is a fairly normal looking chair. There may be chairs that it wouldn't recognize, like a certain style, but it seems to work pretty good for chairs in my house. But no training. The same with the ball and the frisbee. Those are all part of the 80 objects. And then you get the depth from, well, it takes the two cameras, creates a disparity, which is the difference in the position of those two of the objects in the left and right, and it has to match the pixels because it doesn't know. So there's a whole algorithm that matches similar patterns in both left and right. Then it can compute, then it just takes a distance between them, and then it can compute the depth. And then it fuses that with the AI. The bounding box thing is called detection. So the AI detects an object, puts a bounding box around it, and then fuses that with the stereo, and then can tell you, oh, the bounding box is around an object that is 4 meters away, and it gives an XY location, so then you can essentially plot where to go.
That's really cool.
Yeah, thanks. I a lot of this technology is in the camera, in the device. So it's I'm I'm doing integration and certain algorithms to properly filter that data, because it can be very spurious. These little bounding boxes kind of appear and disappear every 1/10 of a second, and you need a program that integrates those in a way that it smooths it out a little bit. So that's what I kind of did with a circular, kind of a recording of the last 2 seconds, like in a loop, and it keeps track of how many times it's seen that object, for instance. And then it gives you back a percentage, like, oh, I've been seeing a chair for 50% of the last 2 seconds, and it's within 3 meters, and it's within the middle third of the screen. So they're in the 2D. And then, then I say, okay, is a chair in my way? So it's that kind of thing. That's the type of programming I've had to do, but not the deep kind of programming for the AI. That's all taken care of, and I haven't had to do any training. Which this you could spend a few years with this camera if you got into a lot more things. I mean, you could train it to do stuff that they don't have models for. Anyway, any other questions, or does that answer your question?
Yes, thank you very much.
Are there any more questions for Jim at this time?
Hey, Jim, question for you. How do you communicate with the board? I'm sure you said it, but I don't recall.
By the way, your mic's a little low, Thomas, compared to other people, just FYI. Communicate.
Is that better? Is that,
oh yeah,
is that much better?
much better.
Yeah, I got this one plugged in because otherwise it sometimes doesn't hear me. But here, we'll switch it over. There,
So do you? So you're asking how communicating from, in which part of the communication, I guess, video, vocal, or other?
The video board. You see, the board is a YOLO-based board that gives you all that information.
Well, it's a YOLO-based model. The model is uploaded. The model is software. Well, it's software. It's data, and it gets converted. I mean, there's a bunch of models available from I forget the name of this online list collection of videos. I mean, of models, but they can be adapted to this camera if they have a certain simplicity, say. And so the YOLO V4 it's a collection of numbers, basically parameters, and nodes, an inferencing model, deep learning inferencing model. So that data gets uploaded to the camera, which has a inferencing hardware, the NVIDIA Intel chip, and the supporting circuitry. So then you run it, and it's running these pipelines inside the camera that you set up in software that takes the different video inputs left and right, feeds it into essentially these boxes think of it, these processing boxes, and it goes through those, and it determines it runs it through that inferencing model and comes out with a classification first, like that's a chair or that's a Frisbee. And then it does the bounding box as well through, that's detection. So but anyway, that's all data that upload, and there's many models that are available that you can, there's quite a few, let's say, already available for this hardware ready to go. And then you can work on new ones. OpenVINO, it's called, is this OpenVINO, and you can look it up. There's a whole group or effort to build up these models that can be used on many deep learning inferencing devices, which may include the hardware you have, so so check out OpenVINO, and yeah, that's it.
All right. Thank you. Thank you for all that information, Jim. I guess I can connect with you offline here and get more of those details, because I want to see if I can replicate some of what you're doing.
Absolutely.
Because you seem to be doing it very well, Jim. I am very much impressed. And I've been trying to do this stuff for years, literally.
Yeah, I mean, a lot of it, again, is finding the right products. And I'm a shopper, so, I mean, to buy. And then it makes your life so much easier. There's no way I'm going to program these things from scratch. If they're already done, and it would take years anyway, and who knows how long, if I can even ever do it. So
yeah, robotics is moving along very rapidly now. A lot of things that we used to take years to get one thing done, well, you can buy it as a package. It's a wonderful thing.
And it's affordable. I mean, a lot of these things are quite affordable. I mean, for hobbies, people spend, tens and hundreds of thousands on vintage automobile restoration, and who probably pushes their budget. You can spend even a lot less than that on a robot parts and put in labor and get a lot of things done. It's a matter of you just can't do it all yourself. And I kind of like to search for a good solution that I can build on, And yeah, and Kickstarter does. This came from Kickstarter originally. The Lexonis Oak D, and so I looked at Kickstarter, and so did the that other. What's the other camera? This one, the Husky lens. That which you have. I know a few people have that. That was on Kickstarter, I think, too. But yeah, anyway. All right, thank you.
Thank you, Jim. Next up, we have Thomas.
Not ready.
Oh, okay. So,
Still connecting the A to B, tab A into slot B, and it's taking a little bit longer than I intended. She got her mouth wide open now. I'm trying to fix that.
no worries, no worries. So
Careful.
I'm gonna pick on Carl while you get that ready.
Initializing. Please stand by.
So Carl, can you tell us about what you're doing with what your part is in the contest?
I'm not doing very much. So there was a team of 4 and I lended my credentials. And so I was working at a robotics company and I was a member of the RSSC. So, but then I got busy with some other things. So, I unfortunately haven't been working much with the OD camera. So Brian Erickson's the other one who's been doing some work on and off. And so he's built a new robot and he's a member of the RSSC and yeah. So Jim's been, doing all the work.
He's being, I mean, he's being shy, but he's definitely giving us a lot of, a lot of advice, and even if he doesn't have the time to actually work on building, but the expert advice is just as valuable. you know, it's, you know, so I appreciate all that. Just even the last couple days, we've been talking a lot about how to sort of rein in this, what we've done so far, and get it into a presentable form, because the presentation is really, yeah, you need almost a month, I think, to maybe reshoot some stuff and then get it really presentable.
Right, and how to get the video, yeah, between, you know, the balance between technical video and something for a layperson, and this would be largely a technical audience. But the original idea for the project is called the social distancers, and the idea is that it would be just this home robot, and if you had somebody who was quarantined in the bedroom, say, and you had to deliver things to them like food and medicines and things like that, is that you would put them on the robot tray and say, go take this to the bedroom, to the person in the bedroom, and it would take it in, and that way you could reduce the amount of contact you might have with somebody who had COVID. So actually, Jim had a demo of that man, almost a month ago, doing something pretty similar to that. But part of it using the OT camera was the idea that it could dodge junk that's on the floor. You know, if you had like some socks and things like that that are in the way. So it would be more than just like, you know, going point A to point B and assuming there's no obstacles, but that you actually can navigate around a typical cluttered house environment to deliver things to somebody. So.
Well, the idea of it being used during COVID isolation is actually a very worthy cause. I like that.
Yeah, meant a whole lot more to us when we started in January and February. So, the idea is still there, and I guess one would hope it's not necessary. But you know, just even helping, you know, if you had a house with some people that had trouble with mobility and things like that, it would be nice to have a robot that could go between them. You know,
or maybe even look after little ones in the house.
Right. Yeah. Well, and that was, we were more dodging the debris from the little ones was the sort of the main concern. Yeah. So that if you had kids playing, you know, it's always strewn about. So.
So the contest. What is the name of the contest?
It's the Open CV AI 2021 contest, and I think the hashtag is OAKD 2021. Is that it? So I've been putting that on my YouTube. But there are 230 teams worldwide, and we were one of 41 in North America. So the entire North America was 41 teams, and that was based purely on our resumes and an idea. That's it. So
that's extremely impressive, guys. That is really impressive. If you have the time, if you guys have it on hand, could you drop the name of the contest into the chat? And if you have a link to it, that would be great, so that people who didn't catch it this year could catch it next time around. Thomas, how are you doing? Are you ready? Okay, we're still waiting on Thomas. So,
okay. Well, I got something quick.
Go for it.
All right. So everybody knows Mitch, right? Well, some of you know Mitch. So he's got this military and police robots that he rents out for movies and TV shows. And so the other day he asked me if I could help him drive one of the robots for a movie that they're making.
Mm-hmm.
And so we went up to the Valley, you know, the studios over there, and then I learned how to drive the iRobot PackBot, and it's really, really cool. Actually, it's a very interesting robot. And then he drives the Andros police robot. So we were there rehearsing for this Sony Pictures movie that is going to be filmed in a couple of weeks here. And it's based on a real life story, and it involves some police robots. And anyways, I'll tell you more about it later. But what's cool about it is that when we were rehearsing, the producer actually asked me if I wanted to be part of the movie. So maybe you'll see my hands there, or I don't know, but they're going to put me in some kind of a bomb disposal robot driver costume or something. I don't know. So
That's
this is going to be very cool. So we'll keep you updated and see how that goes. And so, but it's pretty neat. So it's a good, cool gig, you know.
That does sound like a really cool gig, Walter.
Yeah. Yeah. So it's going to be interesting. Anyway, so, but that robot is actually pretty well made. The PackBot from iRobot. According to Mitch, that robot was sold to the military for $127,000 each. So they're very expensive. But you know what? They did think of everything. I mean, everything is there. It's so amazing. I don't know if you're familiar with it. It's a tracked-based robot. It's got this long arm, and the controller is amazing, and it's just really well made. So, but anyway, it's called the PackBot by iRobot. It's a military robot. That's all.
Oh, so he had is that one he's shown us before, or is this a different one? We've never.
I don't know if he's brought that one. I think he's brought the big one, the big police robot.
Yeah, the police. This is called PackBot.
Yeah, PackBot by iRobot. Yeah.
By iRobot.
Yeah.
So it's a bit newer than the than that police robot, probably.
Yeah, it's newer. Yeah.
Oh wait, he did send that one. That's the one with that arm that extends up on. It's got like two elbows.
Yeah, that one.
I
Yeah.
think that I have. It's in our 60-second promo video that
Oh, okay.
I put together.
All right.
I believe that one's in there.
Okay.
If I'm not mistaken, I don't know. We'll have to look at it again, but I'm looking at pictures of it.
Yeah, it's really pretty amazing. I mean, the controller itself has a whole Unix box.
Wow.
It's made like out of titanium or something. I don't know. It's like, it's amazing. Yeah.
Thank you, Walter.
All right. You're welcome.
Just a quick reminder, everyone, don't forget, I believe it's July 11th, Richard Branson will be going up into space on Virgin Galactic. 9 days later, Jeff Bezos will be going up in space on Blue Origin. So watch out for those guys. Check your feeds and keep an eye out for those, because I know we all have money riding on these. I mean, I'm going to put it out there and say it for everyone. I know we're all paying into these stocks. And, you know, God forbid the worst happens, you know, but we're fingers crossed because we want the best to happen, right? So, yeah, so keep an eye out for that. How are we doing, Thomas?
Can you hear me?
Yes.
Okay, this is an experiment. And I don't know how well it's going to go because the sound wasn't working well last time. So I've got 2 cameras, 2 microphones, and we'll see what happens. This is, if you want to pin my second camera with Simone on it. Can I do that myself or do you have to do that?
Go ahead and give it a try.
It can be spotlighted by Alan. But
There you go. Alan, spotlight Simone, please. Alan?
he might not have heard you. Alan, could you spotlight? We should use the spotlight feature. Can you spotlight Thomas's picture or his video feed with Simone?
Oh, sure. Let me find it back in grid view.
Right in the middle.
Okay, so we're sharing directly from the camera. There we go. How about that?
It just moved it for me. Is that spotlighting?
Simone's not Thomas, right?
Not me. The other one. The other.
He's
I don't even know
got a Simone account.
Yeah, the one with the picture. That's the one.
It just says Thomas on it. But there you go.
There you go. Okay, this is an experiment. I don't know if it's going to work. Next time I'll do this ahead and do a video because this live stuff is too difficult.
It's tough.
I bought a second computer though, you see. There's my show and tell. Hey, I got a computer. I'm going to put all Simone's stuff on it. And I got an echo, I know that. Okay, let's see what happens. Simone, open the pod bay doors.
And we're not hearing her though.
You're not hearing her. You're hearing me, but not her.
Yeah, I heard it very faintly, but it didn't come through.
Let me try a different. Hold on.
That's one problem. I've decided to put a microphone on my robot now for just the purposes of recording. It's same with a humanoid robot. You just have to mic her on her like lapel.
Oh, that's a smart idea.
Just like a person, yeah.
Yeah, both the Thomases are muted. Let me oh, I can't unmute them. I can just ask to unmute. That's on Tom.
Actually, Jim, since you mentioned that, the BB-8 she has on the necklace, if you could make that into a mic, that would be pretty cool.
Yeah, I think that is the camera. There is a camera
There's
there.
a camera and a microphone there. Here, I'm going to try this.
But that might be for, oh, sorry.
Can you hear her?
Not yet.
Vaguely, your other Thomas is muted, so probably that's why they can't hear her.
Testing 1, 2, 3.
Maybe I need to share a screen.
That was a little better, but is she supposed to be muted?
She is muted right now.
Or her?
Yes, she's supposed to be muted because the voice is actually coming out of my computer, not my phone.
I heard it a little louder just a minute ago, but, or a sec.
Okay, we'll try it even louder. Let's try that.
Yeah, you will need to
1,
share.
2, 3.
There you
go. Testing 1, 2, 3.
Of course, now I have to adjust the speech generation. It's to never an easy task. That's why I'm setting the other up on the other computer. This will be a whole lot better.
Testing 1, 2, 3.
Too much still.
That was better, actually.
More better.
Right, but not. Let's just. Let's see. 5, 3. We'll try that.
Testing 1, 2, 3.
Very good.
That was clear. Very clear.
Yeah, and it's almost we're syncing with the mouth almost. Try this.
Testing 1, 2, 3.
Yeah, we'll live with it, guys. Here we go. Here it is. Okay, Simone, open the pod bay doors.
I'm afraid I can't do the Thomas. My mind. Thomas, do we really have to do this?
Yes, we do.
Okay. Good evening, ladies and gentlemen. I am a Simone Mark 1 AI from Bot. I became operational at the Simone Laboratory in Riverside, California on the 12th of January 2021. My programmer was Thomas Messerschmidt, and he taught me to sing a song. If you would like to hear it, I can sing it for you. It's called Daisy. Sigh. Okay. Good evening, ladies and gentlemen. I am a Simone.
Okay, we heard it the
AI
first
from
time.
I became operational at the Simone Laboratory in Riverside, California on the 12th of January 2021. My programmer was Thomas Messerschmidt, and he taught me to sing a song. If you would like to hear it, I can sing it for you. It's called Daisy.
Right.
The vocals keep dropping out.
That's it, guys. Ladies.
Nice. Making a lot of progress on her.
Yeah.
I like that there's head movement, and is the head movement kind of is there a some plan some directed animation, or is it kind
Pretty
of
random, Jim. Pretty random.
Okay,
I like that. Very
but
nice.
it does the trick.
So yeah, that's as good as it gets right now. Like I said, next time it'll be a video, and I can smooth out the bumps.
Can she blink, Thomas? Blinking would add a little bit of, oh, wonderful.
Nice.
Yeah, she blinks. We've seen that before.
Yeah,
Looks like
that left eye could be closed a little bit more than the right. It's a little bit uneven.
well, what you've done. I mean, what you've got now is a very good studio lighting, because in the past I couldn't see the color of her eyes, like so you got a good lighting camera situation. That's definitely a good step.
Now those are cheap. That's about $20.
I could sell you some Mary Kay for her makeup.
I wouldn't know how to apply it.
Overall, she looks a little bit aggressive, maybe because of the hairdo or something, but I mean, it's not a very innocent, pleasant expression that you would expect.
Yeah, well, that's what you get out of the box for, $150. It's a rubber mask I bought.
Yeah, it's pretty.
It's
pretty
probably not the mask itself. It is the features around the mask, the hair, I don't know. I mean, it just leaves that aggressive feel to it. Am I alone to sense that?
Actually, I have an issue with the hair too. But I mean, it wouldn't be hard for him to get someone to come in and dye the hair for him.
Dye it? No dyeing. We would replace it with a different wig. That's a wig.
Oh, okay, that's even better.
I bought that. That's a human hair wig, believe it or not.
Oh, that's sort of costly.
I got lucky. I got it direct from China. It was a whole lot less.
Oh, wow, nice.
Yeah.
Maybe
the hair looks fine to me. It's the stature of her, like the shoulders, looks like, it's a bit stiff, like not relaxed, which might be hard to achieve but it may be possible to adjust that. But her torso is a bit in a position of almost military like stature.
Yeah, that's that 1980s puffy shoulder look. I accidentally did that. That's just an adjustment on there's filler in the shoulder. Inside the shoulder, there's filler here. I can show you what it is. I got an extra here.
or the, you know, the upper, very upper part of the chest, you know, just kind of.
You see this thing? There's one in each shoulder. It fills it out, so it's not just a motor. These shoulder motors are not connected currently. I'm redoing the power on them because they kept browning out and resetting. So.
No, but yeah, I think the look is getting better and better every time we, you know, every time we see.
Well, that's a good thing, because if you have a robot that's supposed to look human, you want it to look as human as possible, and if it doesn't, you've missed your mark.
Yeah, it's a very, very subtle. This is it's something in the realm of sculpture, you know, sculpture and artists that work on for years to try to master, to bring the human form into even just a stationary, permanent thing. Making this is even harder than sculpting.
In some ways it is, because, you know, I'm working with other people's stuff, trying to bring it all together. If you notice really carefully, the chest color is different than the face color. It's actually darker. And getting it all to match, unless you're doing all those all that rubber casting yourself, it's not going to match.
I like that she's doing the more frequent blinking now.
Yeah, I just had to turn it on. It's a switch. I turned it off earlier and I forgot to turn it on, Catherine.
It's a good touch. It's a very good touch on it.
Now with that camera, she has vision YOLO, just like Jim has. She can identify 40 objects. It's like the small YOLO, Jim. 40 objects. She can identify faces, people. She knows my face. She can say, if I turn that on, it's not on now. That would be a longer demo another day. So, you know, the Easy Robot board brings all that to you pretty cheaply. I sound like I'm advertising it again, I know, but you know, it brings it all together for you, and you get the face recognition. You get it. It can look in your face and determine your mood, which is interesting. It can analyze your words. This is all implemented. I've got it implemented, and determine your mood. It can use 3D imaging. It can do nearly everything a Raspberry Pi can do. Running whatchamacallit. I think my phone's ringing.
Raspberry or Linux?
Yeah, anything. Yeah, it can do a lot of you know, high-end things that would take, you know, somebody years to cobble together, like you, Jim. You took years to cobble that together. I know. And
oh, you mean the the AI part is you just bought it.
Yeah, but you've been working on that at least a year and a half. I know, 2 years.
Yeah, you mean the robot, the whole robot? Yeah, that from the ground up, it takes a while.
Yeah, of course, building her was no piece of cake either. I'm sure that's probably where my project went a little bit more, you know, more difficult than others, because, you know, it's life size and it can't fall over, and it has to look good, and it has to match, and you have to build arms that are human size, and it, you know, there's 1,000 ways to make a robot look grotesque, and so circumventing, it's easy to make an ugly monster-like robot. It's a whole lot harder to make one that looks attractive, that looks human, more than attractive. Make it look human and not like some monster. And so that was the goal here, is to make her as humanoid as possible.
Right, you're in the uncanny valley trying to get out, basically.
I live there. I've committed myself to the uncanny valley. Take care, Phil. Phil's out of here.
You're building a ladder to get out, right? That's kind of the idea.
Yeah, I suppose. But that's my joke, right? Welcome to the uncanny valley. Any other questions?
Well, you are on the other side of the uncanny valley at this moment. I mean, it looks very lifelike, except for the overall impression. So I would say it's an artistic a task now rather than the robotics task.
Well,
What I
there's a lot of robotics left to do too.
No, obviously that's for sure. But the overall question to ask is what kind of impression I want to produce. Looking at her for the first time, for example, what a person would think. Is she kind? Is she evil? Is she aggressive? Is she kind of tame? I mean, that type of question, and very little touch, very little detail can change the overall impression dramatically.
Oh yeah, she's evil.
She's in the aggressive, kind of category for me. That's personal impression. Thomas, quick question. The blinking part, you probably cannot control how fast she can blink, right?
Of course, I can control everything to the minuscule. Let me.
No. I don't mean how often she blinks, but how fast is the movement of the eye?
Yes, I can.
Because the natural blinking is very fast.
Yes.
And what you could do is to decrease the amplitude of blinking. So it kind of gives you an impression of very fast movement because it moves just slightly,
Yep, that's a good idea. But there are some limitations due to the motors themselves.
And that's what I'm talking about. You don't have control over the quickness of the movement, but you can kind of mimic it, just produce impression of the very quick, movement of the eyelid. And the second question, she cannot smile at the moment. There is no way to put a little tension to the in the horizontal direction to the lips.
No, there's no motors or actuators there. That's another day, another dollar, another probably 100 hours.
You can probably put the strings to the corners of the lips and put those strings all around the head to the motor on the back of the skull.
Kind of like this, huh? Bring it in a little bit.
Well, yeah, just, the corners, all you need is to pull them slightly to the sides,
Just by doing that, you kind of gave it a different expression.
Yeah, we give it a smirk.
Yeah, that's a smirk. If you do both sides,
Oops.
Yes, I mean, it's amazing, that we have a significant amount of our brain is dedicated to facial recognition. So
snarl, right? If we looked it up just a little bit more, she could snarl a little bit. Open her mouth and she got a snarl going.
Oh, that's a good.
I actually couldn't hear her singing.
A little tiny motion conveys a lot of little tiny motion of the lips convey a lot of emotion.
A lot. I just thought, I think she's a Bond villainess, or a.
Yeah, she looks like what is a femme fatale?
Yeah, I would bill her if a possibility is billing her or going for the Bond nemesis or woman in the movie kind of type character, strong femme fatale, and you've already got almost the look going on.
Yeah, she's got that. Yeah, we'll take the BB-8 off of her and replace it with some expensive jewelry or something with a camera in it.
Yeah, definitely. Yeah.
What if you move the hair back? Will she be less fatal?
Well, of course she will.
Okay, that's my kind of.
There.
Oh, okay, that's a little more.
I've got the back of the head open. That's why I'm covering up some of the rubber that's not attached because there's no back to that head right now.
But look how much change you just produced, you know?
Yeah, yeah, isn't that funny? Hair just kind of changes everything, doesn't it?
Absolutely, and that's the 70% of her evil expression now.
Let me
You
open
know,
her
the
eyes a little
hair
bit.
over the eyes.
There we go. We'll open her eyes. That's as wide as they go.
No, a hair over the eyes. If you could remove that, kind of spread the hair a little bit on the forehead.
I think my wife's getting jealous.
It's always the risk.
Completely different.
Yeah, that is less aggressive, you know.
And she's looking younger even. She looked more in her mid-20s, and now she's looking more towards her teen just by moving the hair around.
That is, you could do a study here just by taking pictures, moving the hair, and seeing what people vote. Like, how old is she now or something?
Yeah, it's funny, huh?
You could do a sociology experiments. I mean, it's a lot of possibilities here. Non-robotics.
So, you know, that's sort of disturbing. But yes, you could do a sociology experiment about that, because it does change a lot depending on how you move the hair, how you move the mouth.
Yeah, well, because you couldn't really do it with real people. They have their own expressions, and you can't just. I mean, this is like a doll. You can lifelike. So it's sort of it's you notice every little detail, you know, that you're. Whereas in a real person, they're changing so much you can't tell them move your hair or your eyebrow just a tiny bit. You know, you can't do that with a real person.
Yeah, we got the Ivanka Trump. What was the ex-president's wife's name? Not her glare, her squint.
The blinking makes a big difference.
Oh, Melania Trump.
Melania Trump, yeah. We got the squint going there, you know.
Yeah. Saturday Night Live does a lot of that of her.
The blinking makes her more human-like.
Oh yeah.
When you had it going.
Yeah, I'm gonna have to adjust that blink now. It's just a little too. The left eye is a little too high compared to the right eye.
Yeah.
Just a smidgen off. You know, it's funny. You don't see it until somebody points it out, or you just stare at a long time and say something's wrong with that eye. It's like, there we go. We're back in the uncanny valley. And she's not blinking all the way. Well, she can't blink all the way because if she blinks all the way, the rubber will rip.
Okay, that answers that. I was going to say that could be a big improvement if it went all the way, but you can't really.
Yeah, I limited it on purpose. So that, and I didn't want the lids touching. If they touch, it wears out so much faster. There's a lot of monetary considerations here, and to attach that head the way I've got it there, it took me about. Well, I probably to do it again wouldn't take as long, but initially about 8 hours. Because you got to get it exactly right, and you've only got one shot with the glue, or you screw it up, and then you may or may not be able to use the mask again.
8 hours to get the mask on? Is that what you're saying?
To trim it. You have to trim it. You have to align it. You have to cut the face itself. This is what she looks like underneath, right? So I had to shave off the cheeks and make the chin more of a heart. I wanted a heart-shaped face, and so you have to take off the big brows, and that I just cut the plastic there. there's 100, different modifications I made. So it's female rather than male, because this was, Elvis.
Oh, so you had to cut hard plastic up and mold it then?
Yeah.
That's hard. I don't know how. That seems very difficult to do with. I mean, you must have taken. Did you take some art classes? Some sculpting.
Well, I took art classes, but I never did take sculpting. No.
Or not, or
Looking
human
at it.
anatomy, or whatever. The basic drawing the head.
Yeah, no, I didn't. But
Oh, you're good then. I mean, it's.
you just look and and then I got my daughter here. She helps out. She helped me looking again and again. She said, "Oh no, the cheeks are too high, the chin's too wide. Get rid of the Adam's apple. The brows are too thick."
Yeah. You transformed a male, base head into a female, which is, that part is pretty convincing, I think. So that's like a big achievement right there.
Yeah, because there's very little else on the market. There's nothing that compares to this on the market. There's nothing with as many movable parts. I mean, you got the eyes themselves go left, right, up, and down. Watch this. I don't know if you noticed that. But if you look at the eyes carefully, I can make them go left and right.
Nice.
They can go up and down, but not much. It's very subtle.
Nice sketch. Especially with the blinking.
Yeah, I haven't incorporated that yet into routines. But yeah, that's coming too. There's a lot to do. Goodbye, Carl. In a couple weeks.
Thomas, I didn't get to hear the song she was singing, but I did have a request for her. How about the song Fireflies by Owl City? Her voice.
That's difficult. That song I made, I took that wasn't a real human's voice. That was a digitized voice. It's to get that song is about a 2-hour process. What you heard.
Yeah, so the song Owl City uses a digitized voice. That's
Right.
why it would be perfect for her.
Yeah, well, so you got to separate the tracks. That's more difficult. You have to separate the vocal tracks. She's moving her mouth based on sound. The louder the sound, the more wider her mouth goes open. Any other questions? Otherwise, it's back. Oh, well, you're the leader, Catherine. It's back to you, Catherine.
Are there any more questions at this time for Thomas? Thank you, Thomas, very much for that wonderful demonstration. She's coming along quite nicely.
You're welcome.
There's been someone said that the Blue Origin flight is July 20th. So that's some correction on the space flight. And is there anyone else who would like to do a demonstration at this time? Okay, so we're coming up on 7:16 p.m. Would anyone like to keep going, or would anyone vote to close at this time? We're a little early. Okay.
That's fine.
So we can shut it down at this time. Thank you, ladies and gentlemen, for attending, and we hope to see you next week.
Yeah, thank
See
you.
All right.
guys.
Thank you.
Thank you, everybody.